So let us have an introduction to Quantum GIS. First of all, let us have some overview of GIS. GIS stands for Geographic Information System, and as per Wikipedia, it is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographically referenced data, that is, they are spatial data. Right from capturing to storing, manipulating, analyzing, managing, and presentation of the spatial data. So this is used in many applications, right from small municipalities to commercial businesses. So what do you do with it, GIS? You can easily measure distances, measure areas, find overlap between features, the proximity analysis, neighborhood analysis. There are many things and many functionalities which GIS provides. So everything is related to location, what Tobler's laws say. This is a simple map, and this has been created by some GIS application. But today we are talking about Quantum GIS, so it was prepared by QGIS only. What you can have as an output from GIS, you can have a map, first of all, printed. So it helps you in cartographic applications. Then you have a digital also, like PDF and JPEG map you can have. You can have spreadsheets, databases, files in the form of shape files and KMLs. Now coming to Quantum GIS is an open source, and it comes with right to, you can download, run, copy, alter, and redistribute the software. So with source code, users or you and me have an option to suggest improvements, to make improvements by ourselves, or you can hire professionals to make changes, and you can save the software for abandonment. There are various licenses for common OS. First of all, licenses to run in both open and proprietary systems like Apache software license, BSD, Berkeley software distribution, and MIT, Massachusetts Institute of Technology. These are the license. So licenses to run in open environment. This were open and proprietary, and this is for licenses to run in open environment. First is GPL, then LPGL, and then MPL. GPL is General Public License, LPGL is Lesser General Public License, MPL is Mozilla Public License. The Quantum GIS project began in February 2002. It was produced by a development team consisting of Gary Sherman, the founder, and the first release was in July that year. The first version supported only PostGIS, or PostGIS we say, and have no map navigation tools or layer control. So we have no navigation tools or layer control. But as the timeline grew, we have many versions of Quantum GIS, and this is how Quantum GIS is. Quantum GIS is GPL, means it is licensed under GNU, General Public License, and there are various versions, and Worklaw is the latest version. This is a simple snapshot of the GIS interface. See how simple it is. GIS is based on plugins, so whatever you want, you can just get the plugin of it, and you can perform your GIS activity. You can add vector as well as raster data. So vector data, it supports all OGR vector formats like shapefile, KML, and comma separated value CSV, microstation, map info. So all that vector data it supports. It also supports all the raster data. These are OGR, and these are OGR raster formats: GeoTIFF, ESRI, Grid, JPEG, and SID and ECW format also. So it read and not write the format like SID and ECW. Support are to be added, and it include with a standalone installer. So still working on it, people are trying it, and most of the functionality is available. Then we have this GDAL, Geospatial Data Abstraction Library, a very important library for people who are working in GIS and image processing field. Approximately 128 formats are supported, and many command line tools are also there, like Convert, Reproject, Warp, and Mosaic. Then this WMS means it is going to web also. WMS and WFS are standards. Web Mapping Service, WMS stands for WMS, Web Mapping Service. The OpenGIS Web Map Service Interface Standards, or WMS. It provides a simple HTTP interface for requesting geo-registered map images from one or more distributed geospatial database. So you can get the data or geodifference map through internet via some service which is called OGC web service. One of them is WMS and the other one is WFS. This web feature service in this interface standard, it provides an interface allowing requests for graphical features, means features, point line, polygon, to web using this platform independent call. That is why we are talking about OGC, which is platform independent. This is your spatial database. These are your WFS server process. The client asks for it, it requests it. The internet, and the remote request goes on, response will come, and the response will go to the client software, and all are platform independent, and OGC is in the background. Now, as I earlier suggested, that plugins are is actually the lifeline of Quantum GIS. So QGIS has standard list of things that it does, like buffering, projection, clipping, union. So there are some things that user want to do that it doesn't. Means you have every plugin which you want. For example, you have SQL query. You can those who are aware of SQL, they can directly query for various fields and records which are available on the, because there are various attributes and records which are available in the underlying database. Now, creating new data and editing, you can create new types of data in Quantum GIS like shapefiles, Spatialite layer, and layers contain basic geometry shapes like point line, polygon. This is of course the vector one. Map projection, of course, as far as GIS is concerned, map projection is a very important aspect in the background. So, geographic coordinate system and projected coordinate system, GCS or PCS. So GCS defines location on sphere model of the Earth, while projected coordinate system, it defines the location on flat model of the Earth. So GCS corresponds to globe and PCS corresponds to the flat model of the Earth. Now this GCS, it defines location with latitude, longitude values, latitude, longitude, and latitude, longitude, these are the angles, one from prime meridian, one from the equator. And this projected coordinate system for a flat map defines location with map units, that means X and Y measured from origin. Projected coordinate system includes unit in feet, meters, a map projection, and underlying GCS. It also has support and coordination with Spatialite. You can make a Spatialite layer, very similar to ESRI's geodatabase format. And all files are kept in one file or database. So all files you'll find in one database only. This can be accessed from number of softwares like Quantum GIS, Python, GDAL, Mapnik. All can have what Spatialite layer you have made. And this can be accessed by these but cannot be accessed by Esri. Then you can make a map, as I earlier suggested that this is very useful for the cartographic applications. So the map view can be exported with Map Composer. You have a fully grown computer manager. Multiple map composition can be stored, and map compositions can be exported to several different formats like PDF, JPEG, and TIFF. This is in this format only you want, or you can send, you can share. So you have Map Composer. The map composition can be saved. Templates can be saved, applied to new map compositions, and you have like the integral part of a map like legend, pictures, and scale bar. So this was a basic idea about Quantum GIS. So good luck with Quantum GIS. Thank you so much.